This is Mrs. Waynert's Math Class, Chapter 1, Lessons 4 and 5, Exponents when used with powers of 10. By the end of today's lesson, you should confidently be able to say, I can use an exponent to show powers of 10. And today we have two vocabulary words. The first vocabulary word is base. Base is the main regular-sized number in a number with an exponent. It's the number that will repeat itself. And our second vocabulary word is exponent. The exponent is the little, fairly odd parent type of number that hovers near the top of the base. It tells the base how many times to repeat itself. Base reminds me of Timmy Turner from the Fairly Odd Parents. It's the big, large number, like Timmy Turner is the big person. Exponent is like Cosmo or Wanda or even Poof after Poof learns to talk. Exponent is like a little Fairly Odd Parent that hovers above the base and talks to the base, telling it what to do. Let's watch a clip from the Fairly Odd Parents.
Cosmo? What are you guys, crazy?
You're a grown man still wearing horsey pajamas and you're asking if we're crazy?
Crazy with excitement!
Happy 23rd birthday, Timmy Turner!
Whoa! Thanks, guys.
Go ahead, Poof. Give it to him.
Thanks, Poof. But you know what I'd really love is get those first words out. Come on, buddy. Let's hear them. What are they, Poof? Come on.
I think he's going to do it.
Well, maybe next time.
So after watching the clip again, base is like Timmy Turner, the big person, and exponent is like one of the Fairly Odd Parents, Cosmo, Wanda, or Poof, who hovers over base and tells it what to do. Let's see what the exponent tells base to do. So exponent hovers over base, and exponent whispers into base's ear, or really yells into base's ear, and says, Base, oh base, you need to show yourself to the fifth graders a certain number of times. The certain number, or the blank, is the exponent's number, and a certain number of times, the times reminds you to multiply the numbers. Let's take a look at the example 10 to the third power. Which number is the base and which number is the exponent? Well, base is like Timmy Turner, it's bigger. So the base is 10. An exponent is like the Fairly Odd Parent that hovers over base. Exponent is 3. So what does that mean? Well, we see the exponent, and what's the exponent going to say? It's going to say, Base, oh base, you need to show yourself to the fifth graders 3 times. This exponent says 3 because its number is 3. So what does that mean? It says base, you need to show yourself to the fifth graders 3 times. Well, what's base? Base is 10. So 10 needs to show itself to the fifth graders 3 times. I have base 1 times, a second time, and a third time. It's 3 times, so I see it 3 times with the multiplication in between. So now I can solve this to find the value of 10 to the third power, and I'll simply say 10 times 10 is 100, because we do the basic facts. 1 times 1 is 1. Tack on the 2 zeros. And then we take that 100 times the 10. That's going to give us basic facts. 1 times 1 is 1. Tack on the 3 zeros. So I get 1,000. Put my comma in. So 10 to the third power is equal to 1,000, or has a value of 1,000. Let's try another example. When doing problems with exponents, they're going to ask you to show different forms. Let's take a look at the different forms. So this page will show us the proper forms of exponents. And the first form we have is exponent form, and that's like the last problem we saw. 10 to the third power. The base is 10, the exponent is 3. The next form I have is multiplication form, so that's what does 10 to the third power look like? It looks like 10 times itself 3 times, because base is showing itself to the 5th graders 3 times. So we have 10 times 10 times 10. And another form we have is the value form. That's what the answer is equal to, or the value of 10 to the third power. We multiplied out 10 times 10 was 100, times 10 is 1,000, so the value of 10 to the third power is 1,000. And finally, sometimes we're asked to find the word form for 10 to the third power, or how do you read it? Well, you read it exactly as we say it. So you read the whole number, or the base, 10, to the, and you pick what the number is, power. Now, you're not going to read 10 to the 3 power. You're going to pretend that you're in line in order, and if you're number 3 in line, you're third in line. So you would say 10 to the third power. If it was 10 with an exponent of 6, number 6 in line would be 6th in line. So you would say 10 to the 6th power. If you were number 25 in line, you would be 25th in line. So you would say 10 to the 25th power. So the word form, when you have a base of 10 and exponent of 3, is 10 to the third power. There is another correct way to say this as well. You could also flip it around and say the third power of 10. So 10 to the third power, or the third power of 10. This is a good page for you to refer back to during this lesson. Let's take a look at example number 1. The directions say write the multiplication form, then find the value. So my number, my base is 10, my exponent is 5. So I have 10 to the 5th power. The multiplication form is the problem I would solve to figure this out. So I see an exponent, and what does exponent say? Base. So base, you need to show yourself to the 5th graders 5 times. And since base is 10, he needs to show himself to us 5 times. So the multiplication form would be 10 times 10 times 10 times 10 times 10, because the base 10 is shown 5 times. What's the value? Well, we need to figure it out to solve it. So I can say 10 times 10, basic facts, 1 times 1 is 1, add my 2 zeros, that's 100. I can multiply that times 10, 100 times 10, basic facts, 1 times 1 is 1, add my 3 zeros on, that's 1,000. Multiply that by the next 10, basic facts, 1 times 1 is 1, add the 4 zeros, so that's 10,000. Multiply that by the next 10, basic fact, 1 times 1 is 1, add on the 5 zeros, and we have 100,000. So when I properly put my commas in, the value is 100,000. Please stop the video and complete worksheet number 1 right now. Let's take a look at example number 2. Here we flip it around. This time it says write the exponent form for 10 times 10 times 10 times 10 times 10 times 10 times 10. Well, if I have to write the exponent form, I know there's an exponent. And I know exponent is going to say base. Oh, base. You need to show yourself to the 5th graders blank times. What's the base? Well, the base is the number that's showing itself. What number showed itself? 10 showed itself. So 10 is the base. How many times did 10 show itself? 1, 2, 3, 4, 5, 6, 7. 10 showed itself 7 times. So my exponent form will be my base, which is 10, and the exponent will be 7 because it showed itself 7 times. The exponent form is 10 to the 7th power. Please stop and complete worksheet number 2 right now. Example number 3, the directions say write the word form for this number. I like to write the word form in the order that I see it. So how am I going to read that? What do I see? I see that my base is 10, so I will write 10. I see that my exponent is 9, and if I'm number 9 in line, what place am I in? I'm 9th in line. Therefore, I say 10 to the 9th power, and that's what I would write in all words for word form. Remember that there is another option. You could also read it backwards, and you can read it as the 9th power of 10. Please stop and complete worksheet number 3 right now. Hey, let's stop for a minute because I'm noticing something that might be a good lazy man's trick. In my first problem, I had 10 to the 3rd power. Multiplication form was 10 times 10 times 10 because base 10 showed itself 3 times. And I found the value by saying 1 times 1 is 1, tack on my 2 zeros, and I multiplied that by 10, and 1 times 1 was 1, tack on my 3 zeros. I got the answer 1,000. The answer has 3 zeros. And notice my 1 is there with my 3 zeros. Notice that my exponent is 3. My answer had a 1 with 3 zeros, and my exponent was 3. The next problem that we did was 10 to the 5th power. Exponent tells base to show itself 5 times. And if I were to go ahead and solve that 10 5 times, I could say my basic facts 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. I keep multiplying 1 times 1. It doesn't change. My basic fact stays 1. Now how many zeros do I tack on? 1, 2, 3, 4, 5. I tack on 5 zeros. 1, 2, 3, 4, 5. And guess what? I have a 1 with 5 zeros, and my exponent is 5. Let's take a look at another problem. 10 to the 2nd power. Exponent tells base to show itself to the 5th graders 2 times. I have 10 times 10. Hey, I think we know what 10 times 10 is, right? 10 times 10 is 100. Let's see how that works. Basic facts are 1 times 1, so I have my 1. 2 zeros that I have to tack on, I have to tack them on, and I get 100. My answer has 2 zeros, and my exponent was a 2. So I'm noticing something. If my base is 10, and only if my base is 10, my answer is going to be a 1 with the number of zeros that my exponent tells me. So it's going to be a 1 with 3 zeros for 10 to the 3rd, giving me 1,000. Or a 1 with 5 zeros for 10 to the 5th, giving me 100,000. Or a 1 with 2 zeros for 10 to the 2nd, giving me 100. So for number 4, my lazy man's trick, when given a 10 with an exponent, the exponent is the number of zeros I add after the 1. So if I have 10 to the 0 power, that would be a 1 with how many zeros? Well, my exponent is 0, so it would be 0 zeros. If I have 10 to the 1st power, that would be a 1. My exponent is 1 with 1 0. That equals 10. If I have 10 to the 2nd power, that would be a 1 with 2 zeros since my exponent is 2. And if I have a 10 to the 3rd power, my answer would be a 1 with 3 zeros since my exponent is 3. Please stop and complete worksheet number 4 right now. Example number 5 takes it to the next level. It says find the value, and I have the problem 52 times 10 to the 5th power. Well, I can use what I know about basic facts. 52 times 1 equals 52. And I can use what I know with the lazy man's trick, as long as the base is 10, and it is. My exponent is 5, so I have to tack on 1, 2, 3, 4, 5 zeros. Put in my commas, circle my final answer, which is 5,200,000. Please stop and complete worksheet number 5 right now. In example number 6, sometimes you'll see word problems like this one. The Hershey factory made 18,000 Hershey Kisses today. What's the amount written as a whole number multiplied by a power of 10? So I see that I have 18,000. They want it written as a whole number multiplied, which is times, a power of 10. A power of 10, powers are like the Fairly Odd Parents. They have powers, right? They have magical powers. So my base is 10 with a little exponent above it. So how am I going to solve this? Well, if I look back at my given number, 18,000, 18 is my basic fact. So I'll write that down. That's my whole number. multiplied by, well, multiplication is the times sign, a power of 10. So I need 10 to the what power? Well, how many zeros are left in my answer? 1, 2, 3 zeros. So therefore it will be 10 to the third power. So 18 times 10 to the third power is the same thing as 18,000. I wrote it as a whole number, 18, multiplied by a power of 10, which is 10 to the third power. Please stop and complete worksheet number 6 right now. Example number 7 is another type of problem you might see with a power of 10. And in this problem we have in parentheses 5 times 3 times 10 to the third equals what? Well, we know we need to solve problems in parentheses first, so I'll circle that and I'll say 5 times 3 is 15. Bring down what I have left, times 10 to the third. Now I have to solve this problem. And I know how to do that. My basic facts are 15 times 1 equals 15. My exponent is 3, so I have to tack on 3 zeros. Therefore, my final answer is 15,000. Please stop the video and complete worksheet number 7 right now. And our final example is example number 8. Lots of examples because there's lots of different ways you'll see these problems. This is similar to example number 7, but the blank is in a different spot. So my problem says, in parentheses, 2 times 6 times what equals 1,200,000. So let's see how to break this problem down. Well, I know in any problem I'd have to solve what's in parentheses first. So 2 times 6 equals 12. And bring down everything else I have, times blank equals 1,200,000. 12 is my basic fact. So 12 times what is going to equal that 12? Well, I know that 12 times 1 is 12. And how many zeros do I have? 1, 2, 3, 4, 5 zeros. What if I said 12 times 1 to the 5th equals 1,200,000? Well, let's take a look at what 1 to the 5th would equal. Oh, that's an exponent, so it says base. So base, you need to show yourself to the 5th graders 5 times. So I would say 1, 2, 3, 4, 5. And if I solve this, I'd say 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. That would say that 12 times 1 equals 1,200,000. And is that correct? No way, that doesn't make sense at all, because 12 times 1 is 12. That doesn't work. So 1 to the 5th power is not going to work. So what number would still give me 12 times 1 is 12, but would show me that I have to add 5 zeros on? That would be a 10. 12 times 10 to the 5th power, because 12 times 1 is 12, and 10 to the 5th power means I add my 1, 2, 3, 4, 5 zeros on. So my answer to this problem would be 10 to the 5th power. Please stop and complete worksheet number 8 right now. So as a review, when we're talking about exponents, if we have 10 to the 5th power, exponent says base. So base, you need to show yourself to the 5th graders 5 times, because exponent is 5. The base is 10, so we would show it 5 times. 10 times 10 times 10 times 10. The value, we multiply it out, and we get the value is 100,000. If I'm given the opposite way, and I have the multiplication form, I see that my base is going to be 10, because that's what's showing itself to the 5th graders. I see it 7 times, so I know my answer will be 10 to the 7th power. When it shows me an exponent form and asks me to show the word form, I like to read it the way that I see it. So I would read it as 10 to the 9th power, because my exponent is 9, and if my exponent was number 9 in line, he would be 9th in line. So I read 10 to the 9th power. It is also correct to say the 9th power of 10. For the lazy man's trick, as long as my base is 10, I can simply write a 1 and add the number of zeros that my exponent tells me to add. So in 10 to the 2nd power, I would put a 1 with 2 zeros, so 10 to the 2nd power equals 100. When I'm asked to find the value and I'm multiplying by a number, I'm going to do basic facts. So 52 times 1 equals 52. My exponent is 5. I add on 5 zeros, giving me 5,200,000. When I'm given a word problem with a number, and it tells me to write it as a whole number, multiplied by a power of 10, I find my basic fact, in this case was 18, and I write that down times 10, because it's a power of 10, so I times 10, and however many zeros I have, that's my exponent. In this case, there were 3 zeros, so I'm going to say 10 to the third power. If I'm given a number in a problem in parentheses times an exponent, I would solve what's in parentheses first. So 5 times 3 equals 15. And then when I multiply that by the exponent, I keep my 15 and add my 3 zeros to the end, giving me 15,000. And sometimes they're asking me for a blank in the middle of the problem, so I would solve what I know. Here, parentheses was 2 times 6 equals 12. I know my answer is 1,200,000. So I say 12 times 1 is 12. I had 5 zeros. But remember, if I say 1 to the 5th power, that doesn't help me. So if I want a 12 with 5 zeros, I would say 10 to the 5th power. Because 12 times 10 to the 5th power, I'd say 12 times 1 is 12, and tack on my 5 zeros, giving me the 1,200,000. Good luck with this lesson.